I hope you still want me. I hope you still need.
So once we pick it, we'll write it here. 15.0, 15.0, 15.0, 15.0. Okay, for us to get our table of values, remember we said that the focal length of a concave mirror ranges between 13 to 15 cm. And so we are taking any number between these two ranges. So we are taking f equals to 15 cm. We put it as our f here. That is our VO they make mention of. Okay. Now they said for us to get our U, we say U is 1.75 to 2.25 and 2.5. So we are to compute them now. U equals to 1.5 times what? What is our F? 15. 1.75 times 15. 2 times 15. 2.25 times 15 and 2.5 times 15. So we use our calculator. We say 1.5 times 15. That will be giving you 22.5. You put 22.50. Then 1.75 times 15. 26.3. You write 26.30. So we are putting everything to be in one decimal place. We are just attaching the second zero. This second zero, we are just attaching it for beautification's sake. We are making everything to be in one decimal place, because the highest value, the least value you can get from a centimeter rule is one decimal place. That is, we have a centimeter rule this way, and here is 0 and here is 1. The least you can get here is 0.1, 0.2, 0.3, 0.4. You can't get 0.11. You can only get 0.1, 0.2, 0.3, 0.4. When you get to 0.9, you get 1.0. That is what we say. So if you are writing any two decimal place of a thing, it means you are wrong. Are you getting it? So try to understand. We are just putting the second zero to make it what? Be well packaged or to be beautified. Okay? So we now said 26.3. Then 2 times 15. 2 times 15 is 30. 30.00. Then 2.25 times 15. That is 33.8. Then 2.5 times 15. That is 37.5. So we have gotten our object this time because they gave us what to use to get it in the procedure. Now to get our V, we know our F, we know our U. Are you getting it? Since we know our F, we know our U. Recall that 1 over F is equals to 1 over U plus 1 over V. Making 1 over V subject to formula, this will go the other side. Therefore, 1 over V will be equals to 1 over F minus 1 over U. Okay? Now, looking for the LCM, you will notice that here is UF. This times this will be the LCM. This divide this. U times this U. Minus this divide the F times this F. You have it this way. Okay? 1 over V equals to this. Okay? Then your V will be equals to, if you invert this, you get V. If you invert this, you get the equivalent. So Inverting this, you have V. Inverting this, you have this over U minus F. So this is the formula we are to use to get our V. Yes, we say the first is V equals to, what is our U? Our U is 22.5 times 15 all over 22.5 minus 15. After doing that, we change that 22.5, we change the next. Okay, we use our calculator. We say 22.5 times 15 divided by bracket 22.5 minus 15. That will be giving you 45 cm. We write it here, 45.00 cm. Then we change this 22.5 to 26 point what? 3. We change it to 26.3. We change this to 26.3 because the U now change now. We use our calculator again. 26.3 times 15 divided by bracket 26.3 minus 15. That is 35 approximately. Okay, 34.90. 34.90. 34.90. That is what we are getting it to be. Okay. So we go for the next one, 30. We change 26.3 to 30. 26.3. We change it to 30.0. Let's write this clearly. Okay. We now have it to be 30 times 15 divided by bracket 30 minus 15. We'll be having 30. So when it is 30, we have 30. We now change 30 to 33.8. 33.8. 33.8 minus, okay, times 15 divided by bracket 33.8 minus 15. We'll be having 27.0. Then we'll do the last one, 37.5. We say bracket 37.5 times 15 divided by bracket 37.5 minus 15. That will be giving us 25. Okay, so we have gotten our V. Now, to get our 1 over U column, we will be inverting everything we have here in U column. We get 22.5 inverse 0.0444. Now, because 1 over U is not gotten from measuring instrument, are you getting it? It's just what you get from calculator. It's gotten by calculation. It's not by measurement. It doesn't have reading accuracy. So we can put it in 3 or 4 decimal place. And so we'll be having 0.044, 26.3 inverse 0.038. We have 30 inverse 0.033. The 3.8 inverse 0.030. Then 37.5 inverse 0.027. Okay, we have gotten the inverse of U. For inverse of V, it still doesn't have reading accuracy. That is, you don't get it from measuring instrument, you get it from calculation. And so inverse of V means we have to get inverse using calculator of all the values of this V. So 45 inverse 0.022, 34.9 inverse 0.029, then 30 inverse 0.033, 27 inverse 0.037, 25 inverse 0.04. So you have gotten this inverse. Then UV means multiply U to V. 22.5 times 45, 1012.50. Then 26.3 times 34.9, 917.87, 900.00 times 27, 912.60, nine three seven 0.50. So we have gotten our UV as well. Then U plus V is what? Add your U to your V. Then 2.5 plus 45, 67.50, 26.3 plus 34.9, 61.20, 60.00. This to this, 60.80. That's 7.5 plus 25, 2.50. So we have gotten our table of values for this experiment without performing it. Are you getting it? Just first row, pick a range of value. Pick from the range of value of focal length, pick any number, whether 13, 14, 15. After picking it, then use the formula as I discussed and what package your table. Yes, that means in some cases, it's not a must that your decimal place must be uniform. Yes, it's not compulsory, but you have to what? Maintain it in that column. You have to maintain it in that column, okay? Okay, let's see how to plot the graph. The question is, plot a graph of UV against U plus V, starting both axes from the origin. Obtain the slope and the value of y-intercept and state the physical meaning of your slope. Estimate the standard error in your slope and y-intercept. Now, for you to understand what you are asked to do properly, Remember we use 1 over f equals to 1 over u plus 1 over v. This is mirror formula. If you look for LCM, it will be uv, right? 1 over f equals to this divide this v plus this divide this u. So you have 1 over f equals to v plus u all over uv. Therefore, carry uv up, that is cross multiply uv times 1 uv equals to f times this f bracket v plus u. So you have uv equals to f bracket v plus u. That tells you that when you plot a graph of uv against what? V plus u, f will be your slope. Whatever you get as your slope will be your f. That is focal length of that what? Mirror. Okay, we have gotten the idea of what they asked us to do. Now for us to plot the graph, first thing to do, write your date of your experiment, write the title, a graph of uv is cm squared against v plus u or u plus v, whichever one, is cm. Once you write your title, remember that they said starting both axes from the origin. Look at what you have to plot, this and this. But the lowest number we have here is 937.5 and the lowest for this one is 60. If we are starting from the origin, we have an issue. That is, we have empty or vacant space. And so we will now apply another principle of indicating we are starting from the origin. This is uv, right? uv for vertical. Okay. So let me count 1, 2, 3, 4, 5, 6, 7, 8. If I say here is 900, 910, 920, 940, 950, 960, 970, 980, no. 900, 900, 920, 940, 960, 980, 1000, 1020. That means what I will do is to show to them that I am to start from the origin. I will use zigzag line and put here and put zigzag line here. It means that when they see this, it shows that I am observing the rule or starting from the origin, but I didn't what? Indicate that 0,0. I am observing the rule that I'm starting from origin, but I didn't what? Show 0,0. That is what this zigzag line means. That means I will be writing here now 900, 920, 940, 960, 980, 1000, 1020, and the highest is 1012. So I will label the Cartesian axis. This is what? uv is cm squared. Yes. We'll go to the other one, u plus v. To get the u plus v, the least is 60 and the highest is 67. So if we say that here is 60, 61, 62, 63, 64, 65, 66, 67, we can go by that. We say 60, 61, 62, 63, 64, 65, 66, 67, 68. We said here is u plus v, the unit is in cm. Remember we said choosing appropriate scale is very easy, and we don't use formula anymore because we have been conversant with all this choosing appropriate scale. We want to see how we do it bit by bit. All you need to do is to click the Chidon's Daniel. Click Chidon's Daniel on YouTube. Chidon's She understanding how to choose appropriate scale. When you do that, you will be able to watch, see the video. She understanding how to choose appropriate scale. You watch and see how you do the manipulation or you get your appropriate scale to be used. Are you getting it? And so we want to now see how to what? Locate it. So you have to write your scale. You have to write your scale, so to speak. You have to write your scale after you are done with the graph plotting. Get the mean of u plus v and mean of uv. You will be having 67.5 plus 61.2 plus 60 plus 60.8 plus 62.5. That will be giving you 312 divided by 24 divided by 5, 62.4. Then you do it also for the second one. 1012.5 plus 917.87 plus 900 plus 912.6 plus 937.5 divided by 5. You'll be having 936. You'll be having 936.1. Now, this is what you use to get your centroid. Alright, let's see our plotting. 1012.5 against 67.5. 1012.5. This is 10,000. This minus this will give you 20 divided by 10. That is 2. So 10,010 should be here. So we take it from here against 60 what? 7.5. Then we take again 917.87 against 61.2. 61.2. 91 what? 7. 917 will be close to 920. 61.2. Okay. Then we also take another one. We will say 900 against 60. 900 against 60. Then 912 against 60.8. 912 against 60.8. 912. Wow, it should be up. In between this and this 910, so 912. Then 937 against 62.5. So we have located our, then we have to locate 936 against 62.4. This 62.85, 62.4, there should be what? Close. So that's 937 against 62.5, 936 against 62.4. They intersect because they are almost close. Then that means your line of best fit should pass through this centroid. We call this second part the centroid. Okay? Don't forget to include your scale. Your scale says in UV axis 2 cm is equals to what? 20 cm squared. and in U plus V axis, 2 cm is equals to 1 cm. So let's draw our line of best fit. Wow, we have located our line of best fit, as you can see. Okay, yes, it passes through the centroid, because we say a good line of best fit must pass through the centroid, which we have. Remember, we said this is just a sketch of the graph. Just use a standard graph sheet and do the graph plotting. Tell us what you get as well. Okay, so we have gotten our line of best fit. Next is for us to get the slope. To get the slope, we also draw a vertical and horizontal line. Okay, I've drawn my vertical. I call this one change in UV equals to, I call this one change in U plus V equals to. Now, the highest point here is taken to be 1012. So we can take here to be 1012 minus the lowest point is 900. Then for this one, we take care to be what? 68 minus, take this point to be what? 60. We have that our slope is equals to slope of best fit equals to change in U V all over change in U plus V. And that gives you 1012 minus 900 all over 68 minus what? 60. And so we use our calculator. 1012 minus 900 will give you 112 all over 68 minus 60 is 8. You say 112 divided by 8. That should be giving you 14 cm. Still in the range we said it should fall between 13 to what? 15. Are you getting it? Cm. We have gotten our slope. Then they ask us to get the value of y-intercept. The intercept mean where it meets the vertical axis. Intercept on what? UV axis. Since this indicates I am observing starting from the origin, but I didn't indicate 0,0. It means that from here to here covers from 0 to 899. From here to here covers from 0 to 899. Then you now start 900 and above. And from here covers 0 to 59.59. Then you now start seeing 6061. So because it passed through this midpoint, it means that the intercept is equal to 0 cm. It passed through the origin of it. Meaning here is origin, then you start seeing 900. Means 0 to 899 is what discovered, and 0 to 59 is what discovered. So we have 0 cm. Estimate the standard error in your slope and y-intercept. Since none of the points fall out, are you getting it? If there is any point that fall out, we connect it to this what? To this centroid and get this slope, get the difference. Then you get the error in slope. Then we also take it to the y-axis, get what it gives you in the y-axis, get the difference, you get error in the what? Intercept. Are you getting it? So if we have it this way, and this one is the slope, if it also have another point that fall out, maybe here central, you connect it together to get the slope of the second one this slope of worst fit, where it cuts y-axis and where this one zero origin, but this minus this or this minus this, you get the what? Error. But the error must be positive, so that if you say this minus this, you get the modulus of it. That means forget about the minus sign. Then the slope of this worst fit and slope of this best fit, get the difference and make sure the answer is positive by neglecting the minus sign if it gives you negative. Are you getting it? Then you get it to be the error in slope and error in intercept. But coincidentally here is zero. Everything here is zero. The error in intercept is zero and the error in slope will be zero because none of the point fall out for us to get their slope and subtract. Okay, so we are done with this. The next question is estimate the radius of curvature of the concave mirror. Now we said from here that y equals to fx. When you plot the graph of this against this, they become the what? Focal length. So this becomes automatically your focal length, which you talk about. And so what happens now is, since radius is equal to 2f, radius of curvature equals to 2 times focal length, we say 2 times 14, that will be giving you 28 cm. That becomes the radius of curvature of the concave mirror. Okay, so finally, where should an object be placed in front of a concave mirror so that it produces an image at the same location as the object? Is the image ray or virtual? Is the image inverted or upright? What is the magnification of the image? This is just a miscellaneous questions. Now, how do we do that? They say, where should an object be placed in front of a concave so that it produces an image the same location as the object? That means your u is going to be equal to v. Your u distance is equal to v distance. Are you getting it? Now we have that 1 over f equal to 1 over u d plus 1 over v d. So if this is meant to be equal to this, it means that 1 over f is equal to 1 over u d plus 1 over u d. Vd will be equal to what? ud. Okay, looking for the LCM, we have that 1 over f equals to, LCM will be equal to ud. This divide this one times is 1 plus this divide 1 times is 1. 1 over f equals to 2 over ud. Cross multiply. This times is ud equals to this times is 2f. Now, in problem of light or problem of mirrors, we noted that 2 times focal length is called radius of curvature. That means ud, which is the object distance, should be located at radius of curvature for it to give you the same size as the what? The object, or the same distance as the object. So once it is located at the radius of curvature, once the object distance is located at the radius of curvature, it means that the image will also be located at the radius of curvature. Yes, but in this case, the image will be inverted. The image will be inverted and the image will be real because it is formed on the same side of the object. Yes, it is formed on the same side of the object. Look at your what? Your F, and look at your what? Your C. So once an object is located here, that is the center of curvature, it means that the image will also be located at that center of what? Curvature. This is your F, this is your what? C. So this is your what? F, and this is your what? C. Now look at the object. If the object is 2 cm height and this is the distance, it means that it also form an image which is 2 cm size still at the center of curvature. The point where the radius of curvature is located is called the center of curvature. So this is the image and this is the object because it is located at the what? Center of curvature, which is 2 times principal focus. So it will be inverted, and because it is still formed on the same side of the what? Object, we call it that it is real. Now for the magnification, so is the image real or virtual? It is real because it is formed on the same side as the what? Object. Yes. Then is the image inverted or upright? It is inverted, as you can see. What is the magnification of the image? We noted that magnification is equal to V over U. Yes, since this V is equal to U, we said U is equal to U because they are equal. The distance of the object is equal to the distance of the image, and so they will cancel to give you 1. It means that the magnification is 1, and this is inverted and this is real. Okay, so as you enjoy this video, please feel free to click subscribe, click like, turn your notification button on. Are you getting it? So feel free to share to your friends so that they will learn too. See you in the next practical class.